Hi all, let's continue with the series of bit manipulation, and the problem we are looking today is single number 3. So this is a continuation problem for the previous one. You can tell as extension for that. A bit more complex, but it's easier if you understand the approach. So let's go with the approach. This is the problem statement. Given an integer array, nums, in which exactly two numbers appear only once and all the other appear exactly twice. Find the two elements that appear only once. You can return the answer in any order. You must write an algorithm that runs linear runtime complexity and uses only constant extra space. So this condition is same as the previous problem. We need runtime of big O of n and space complexity is O of 1. So the only difference here is instead of one unique number, you have two unique numbers and remaining all have duplicates. So everything is repeated twice. Now in this example, 1 is repeated, 2 is repeated, 3 and 5 are unique numbers. So we have to give output of 3 and 5. And this second example, -1 and 0. So if there are only 2, we will return the array directly. Even here, 0, 1, we can directly return that. So this is the problem statement and these are the conditions. Let's see how can we solve this problem. Now, let's consider this one. Just a second. Yeah, this is nums array, which let's take this as example 1, 2, 1, 3, 2, 5. And previously, have you seen what we have done if it is only one unique number? If it was 1, 2, 1, 1, what we did was we did XOR of all this. So this and this gets cancelled out and this will remain. This was our previous approach. Now we have two numbers like this. So we have to, and we have to find these two. So let's take this as example where 1 and 2 is repeated twice and 3 and 5 are the unique numbers. Let's do the same way which we have done previously. We have to do XOR of all the numbers and this will be the output because all this gets cancelled out and we will get XOR of 3 and 5, that is 6. So 6 in binary is this. Now we want the individual numbers, not the XOR of these two numbers. That is the catch here. So what does XOR mean in first of all? We got 1, 1, 0 when we do XOR of 3 and 5. What does that mean? So 3 is 0, 1, 1 in binary format and 5 is 1, 0, 1. So what XOR generally represents is the bits where these both numbers differ. As you can see, in the first bit both are 1, so that will be 0, and remaining two bits they are different. So XOR is indicating in these two particular bits the number 3 and 5 differ in their bits. So XOR gives the all the bits where both number differ, because if it is same we return 0, right? So that is what XOR means. Now with this approach, if you think a broader way, we want these two individual numbers. We have XOR of them. So how do we split these two numbers is the point. As we are returning those two numbers, we need to split them in some format. So there should be some difference between them to split, right? For that difference, we get this rightmost set bit. So rightmost set bit is something we are finding, like in this now example, if you take 6, the rightmost set bit for this is this position. So from right, if you consider what is the set bit, that is rightmost set bit. So except this, remaining everything will be 0. So it will be like from right, this is the first set bit and remaining all will be 0. This is the rightmost set bit for 6. So before telling why we are using rightmost set bit, let me tell you how it is done. So how do we find that rightmost set bit is? Now let's consider for 6 itself. This is the just a second. So this is the binary of 6, 1, 1, 0. Now As you know, this is the ones complement of 6. That is, just we flip zeros with ones. This is ones complement, and this is two's complement. Two's complement is just we add 1 to the ones complement of the number. So if we add 1, 1 will go here, and this will become 0. 1 will come here, and this is 0. So we got the two's complement. So this is the two's complement of 6, and this is 6. Okay. So what do you observe here is, rightmost set bit is, we have to find the bit that is set from the right, first bit that is set from the right. Now, generally in one's complement we flip this. In two's complement, what exactly is happening? If it is 0, in ones it becomes 1, and if we add 1, that 1 will shift towards left till we find a 0. Okay, I will explain it once again. So now this is the original number. If we do ones complement of it, we get inverted of that number, 1 0 0. So in two's complement we add 1 at the end, right? So in the rightmost set bit, if there is a 1 and you add 1, just like the case we are doing here, so by adding 1, the carry will go to the left and we get 0, and the 1 will be in the output until we have 0 here, right? Because if we have 1 here, the 1 will again left shift to next left position, and the carry will be here. And if it was 1 here and it was 0 here, here we get 1. Basically, wherever we have 0 here, we are getting 1. That means if it is 0 in one's complement, it is 1 in original array, right? I mean original number. So basically we are finding the rightmost set bit from this two's complement. That's what. See, this is the two's complement. But the problem is, like in two's complement we'll get many ones. We just want only one. That is the first right set bit. So the two's complement we will do AND with the original one, because remaining all other bits will be flipped, and if we do AND, that will become 0 except this bit. So we do two's complement AND with the original number. So that gives rightmost set bit. So rightmost set bit is a number and of two's complement of that number. This is what we do, because that two's complement gives the positions that we have 1, and AND of that number will be AND of two's complement will be like flip of that, right? So remaining all will be 0 except that rightmost set bit. Hope that made sense. So why we found this rightmost set bit is, as you see, XOR gives all the positions that differ in these two numbers, but we just need one position, right? Why all the positions? So that is rightmost set bit. If we have one position, and if we can try doing AND with these two numbers, the rightmost set bit, then we either get 1 or 0, because in that position it differs. So if we do AND with 3, it will become 1. If we do AND with 5, it will become 0. So that is the difference between two. So with this logic, we can differentiate these two, right? So that's the approach here. After finding rightmost set bit, we have to do grouping. So yeah, now as I told, 3 and 5 will be two groups. Like now 3 and 5, sorry, not exactly and, 3, 5, we have to split in two groups. Let's say 3 is in group A, 3 is in group A, and 5 is in group B. And we have to make the entire array to split in A and B. That's what we'll do. So this is entire array. Now, if we do AND of each element with the rightmost set bit, we can split in groups. Let's see how we did. Now, this is 1 And rightmost set bit we got here from this is 2. So if we do 1 AND with 2, we get 0, which we can consider as B. That falls into 5 group. So if you do 2 AND with 2 itself, of course it gives the same number. And 2 we can consider as A. So it's like 0 and non-zero groups. And if you do 1, as we can see, it will be in group B. And with 3, as we saw previously, 3 is a 3 which sets the bit. So it comes in group A, and 2 comes in also group A, as we saw here. Then 5 falls in group B. So by doing AND of rightmost set bit and that number, we could split them into 2 groups. We got it, right? So now group A we had 2, 3, 2, and group B we have 1, 1, 5. So duplicates we can eliminate here. How can we eliminate? We just do XOR of this and this gets cancelled out, and XOR of this and this gets cancelled out. And these two will remain. We can return both. So we got the approach. That's what we wanted, right? We have to return 3 and 5. So just a recap of what we have done. Firstly, we have to do XOR of the entire list of elements to get the XOR product of both unique numbers. That is 3 and 5 XOR, which we got as 6. So now we have the XOR, not the individual elements. So we have to split them somehow. For that we use rightmost set bit. Rightmost set bit is the bit from the right, that is first set. So to find that, we have to do AND of the number and 2's complement of that number. So that will give the rightmost set bit. After getting the rightmost set bit, if we do AND of every number with the rightmost set bit, we can split them into 2 groups. So if the AND is non-negative, then it is a group B. If it is, okay, I'm not non-negative. If the AND is non-zero, it will be group B. If it is 0, it is group B. Or it can be either way. So after splitting into 2 groups, what we do is again XOR of these 2 groups. So if you do XOR of these 2 groups, then automatically the duplicates cancel out as they fall in the same group, and the unique number will remain. Similarly here. And we can return these 2 numbers. So that is the approach. Hope you got the approach. Okay, now let's see the C++ code for the same. So this is the code. First we initialize X, A and B. So X is the XOR that we get when we initially do the XOR of all the numbers, and N is the array. So A, B are the groups that we are dividing. So firstly, we run a for loop in the entire array and get the XOR product of all the numbers. So everything gets cancelled out and the XOR of the unique number remains in the X. So now we have to split this X into 2 groups, A and B. Before that, we'll find the rightmost set bit, which will be long int. And if we do AND of 2's complement of X and X, we get the rightmost set bit as we discussed. Now, using this rightmost set bit, we can divide them into groups. So again, we run an iterator for all the elements in the array, and we do AND of rightmost set bit and with that number. So if it is a value, that means non-zero, then store it in array A, not array A, store it in A. How we are doing is directly here itself we are performing XOR. So A equal to A XOR n of that number. So we are doing XOR. So when duplicates getting getting added, then XOR of those duplicates will become 0 and unique number will remain in the group A. So if it is non-zero, you do XOR with A. If it is 0, you do XOR with B. That's all. So, and A and B will have the unique numbers. You return them by typecasting to int and they are asked in a vector int format. So you just make them into a list and return. That's it. So if you run this, it passes all the test cases, and if you submit, thank you. That's all for today.